On the board, there are 6 molecules of alkenes. Your task here is to determine if the alkenes are classified as trans, cis, or neither. So let's go through one by one. For this alkene here, we look at the carbon-carbon double bond and again use the fingers to decide. Here we have a methyl group going up this way and an ethyl group going down. On the right carbon of the double bond, we have a ethyl group at the bottom and a propyl group at the top. So propyl, methyl, ethyl, ethyl. Ding ding! We see that there's some similarity here. In fact, they are identical. Ethyl on each of these carbon-carbon double bond. Now, when we draw this dotted line here, we realize that they are from the same side. So that means this alkene is cis. The next molecule. At the double bond, again, we go methyl, and this is what? Isopropyl, or we can call it methyl ethyl. The right carbon, that's a methyl, bottom is a ethyl. So we have a hit, methyl, methyl on each of the carbon at the alkene bond. And again, it's the same side. So this is cis. For this case, take a look. The first substituent here is a 1, 2, 3, 4. What is it? It's a third butyl group. At the bottom is a methyl group, right side isopropyl. This is N-propyl. So they're all different. So this is neither. For this case, double bond, we see fluorine, fluorine, chlorine, and methyl group. But for here, do not be fooled that because I have got 2 fluorine, then it is cis or trans. Because both fluorine are connected to the same carbon of the double bond, which makes it unable to be classified under cis or trans. So we always look at the carbons at the double bond and then we compare these 2 sides here. Do we have something similar? Chlorine, methyl on the other side? Not at all. So this must be neither. For the next case, do carefully. For this carbon, we have a methyl group, and at the top here, we have a bromomethyl. On the right, we have a bromo, and the bottom is an ethyl. So again, they're all different, so that's why it's neither. You have to go atom by atom. Do not be fooled and say, oh, there's a Br, Br, they're the same. But they are not, because when they go, the first bond, it reaches the Br here, but on the left is a carbon. So they are different. For the last case, I see a methyl, 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 and H. When you have 2 of the same kind of groups attached to the same carbon in an alkene bond, it just makes it unable to have cis or trans. So again, this is neither. I'm going to draw you one example of a trans here because there is an example. So a double bond with fluorine up here, and on the other carbon of the double bond, you draw fluorine down. This is a trans alkene. Trans, you can think of it because of the 2 fluorine opposite side in the double bond, or you can even look at something that's hidden. The hydrogen is not shown. Again, they are also on the opposite side. So this is a trans.